Hello everyone, I am Dr. Fausulati. I am giving some series of lecture for the course Discrete Mathematics. So in the first lecture, we talked about what is a proposition, and then we learned few compound proposition like negation of a proposition, then the AND operator, OR operator like conjunction of proposition, disjunction of proposition, and their truth value, right? So in this lecture, we are again going to learn few more compound proposition, and we'll start with the exclusive OR of a proposition. Now, what is exclusive OR? Like you will have two existing proposition. One is P, another one is Q. One is P, another one is Q. Then we'll create a new proposition with the help of these two with this operator exclusive OR. Right? And this exclusive OR operator works like this will be true if one of them is exclusively true. Not both should be true. Right? So P and Q, this is true whenever exactly one of them is true. That means it is exclusively one of them is true. In all other cases, it is false. So if P and Q both are true, then it is not exclusively true, right? So therefore it is false. But one of them among the both, if they are true, then it is true. And if both of them are false, then it is false. So if that is the case, then if we write the truth table of it, we can say that P, Q, P and Q, then what should be the truth table of it? Consider all possible cases, T, T, TF, FT, and FF. These are all full possible cases, and we have seen that both of them true means it is not exclusively true, therefore this will become false. But one of them are true, that means exclusively P is true, therefore this will become true. The next one is also become true, and both of them are false, therefore it will again makes it false. So this will be the truth table of this one. Correct? So these are all easy kind of thing that the truth table of it and the truth value all are easy, and student may have learned these things, that AND operator, OR operator, or exclusive OR operator in their +2 level in physics course also, right? In case of a gate they have learned, or in terms of Boolean variables 0 and 1, right? Either 0 or 1, this kind of thing student used to learn there. So now you will learn a new proposition called conditional statement. That may be new to you. So let P and Q to proposition. Then the conditional statement, I have two proposition P and Q. Then the conditional statement is denoted by P imply Q, like this arrow. And what is it mean? You read it as if P then Q. If P then Q. Right? So this P imply Q is related to if P then Q. Now, before discussing its truth value, let us understand this through example. Consider this statement that if I am elected, then I will lower your taxes. Now we know that basically politicians used to make this kind of statement. They used to give this kind of promises that if I am elected, I will lower your taxes. Now you suppose some politicians have made this statement, right? So this statement is either true or it is false, right? That he or she has made a correct statement or wrong statement. Now you try to understand the case when you can say the politician was wrong. If you just look at this statement and then tell when you can say that this statement is false, the politician made a false statement. Think of it. Yes. So if the politician is elected but not lowering your taxes, then only you will say it is false. No? So if the politician made this statement at the beginning, and you are now judging that whether the statement was correct or not, whether the statement was true or false. So you will be judged on the basis of the fact that if the politician is elected but not lowering your tax, then you say that the whole statement will be false. Then you will say the whole statement will be false. In all other cases, thus you cannot deny the statement, right? In all other cases, you cannot say the statement is false. Then it should be true. So if the politician is not elected, then it is not his or her responsibility to lower your tax. So in that case, the tax may be lowered or may not be lowered, but his actual statement is correct, true. Correct. So therefore, again come back to this statement P imply Q. Therefore, this P imply Q will be false if you have this P is true but Q is false. If you have P is true but Q is false, then only it is false. But in all other possible cases, it is true. I hope you understand. So in this case, if I want you to write, if I ask you to write the truth table, what will happen then? P, Q, P, and Q. P imply Q. So take all the possible cases. T, 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 F, F, T, and F, F. So P imply Q will be, this will be true, but only possible cases where it will be false, it is this case, right? Only possible cases it is false, like P is true but Q is false, then only it is false, but all other cases it is true. Therefore these are all true. So student used to think that F and T, so this case also, how can it be true? Student used to get some confusion. Now see, you are not judging that what is the fact, you are judging the this statement is true or false. If I am elected, then I will lower your tax. Now, in reality, the politician is not elected, and it lower your taxes. Somebody lower your taxes. So, on the basis of that, you cannot say that this is false. So, the initial statement was true, na? Right? So, even if you have this is false, this is true, then also P imply Q will be true. Right, this part need to be clear. So it is only when it will be false if P is true and Q is false. This is the only case you will have, it is false. In all other cases it is true. I hope you understand. This is very small logic involved here. And in this kind of statement, P imply Q kind of statement, the P is called the hypothesis or the premise, and Q is called the conclusion or the consequences. Right? So hypothesis and the conclusion, or premise or the consequences. So we'll see that in several places we'll be using this fact. Yeah, as we discussed, that P imply Q will be false only when P is true but Q is false. This is the only cases where you'll have false. In all other cases, it is true. So this is the truth table of it. Now again, my suggestion, as I mentioned in the previous lecture as well, that please do practice this kind of small proposition and their truth table, because we are going to use them in big truth table to understand more logic, right? Okay. Now this P imply Q have some more terminology. So we already understand it means that if P then Q, but sometime you may say that if the same statement, equivalent statement is P implies Q, or you can also say P is sufficient for Q. You can also say Q whenever P only if Q is necessary for P, or Q is Q when P. So these are some different terminology you can use for the same conditional statement. I hope it is clear. Now I have three more compound proposition which we can create from the conditional statement this P imply Q. Right? So we have three compound proposition from this conditional statement P imply Q. One is the converse of it is Q imply P. Converse of this is Q imply P. Then the contrapositive of it. Contrapositive of this P imply Q is not Q imply not P. And I have inverse of this conditional statement is not P imply not Q. So there are three compound propositions that you can have for the conditional statement P imply Q. So Q imply P is the converse of P imply Q. Then not Q imply not P is the contrapositive of P imply Q. Contrapositive of P imply Q. And not P imply not Q is the inverse of the conditional statement P imply Q. right? So these things again you should remember, and we'll see that a few of them actually have the meaning is same, logical meaning is same, right? So just before going to that, we have one more thing, that when two compound proposition always have the same truth value, we call them as equivalent. When two compound proposition always have the same truth value, we call them as equivalent. So let us see some example. What do you mean by equivalent? So the first example is, so that a conditional statement and its contrapositive are equivalent. So what do you mean by conditional statement? You have to show that P implies Q. This is called a conditional statement. And its contrapositive are equivalent. So you have to prove that this one, what is the contrapositive of it? It is not Q imply not P. And they are equivalent. You have to prove that. So equivalent, we can take this notation. I'll discuss about it in the next slide also. So P imply Q is equivalent to not Q imply not P. This is the sign of equal. So required to prove this one. We need to prove this. But how do you prove that? What do you mean by equivalent? Equivalent means that whenever they have the same truth value. So how do you check that whether they have the same truth value or not? Using truth table. Let us do the truth table. So what we'll do, we'll create some truth table and we'll take all possible cases and we'll see whether they have the same truth value or not. So I require P, Q, I require not P, I require not P also, and then P imply Q, and I require not Q imply not P. So these are the things I require. So I'll create the truth table with the help of them. So this is the truth table. I'm going to do it. Then you take all possible cases, that true, 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 false, false, true, and false. Then what is not Q? If this is Q, this column is for Q, then not Q is the exactly opposite of it. So false, true, false, and true. The not P is opposite of this. So this will be false, false, true, and true. Now we know that P imply Q. This is P imply Q. This will be false only when you have T is true but Q is false, right? This is the only case where P imply Q. So this will be false. In all other cases, it will be true. So therefore, this is the one. And the last one is not Q imply not P. So again, it is kind of conditional statement only, not Q. The first one imply the second one. So whenever you have the first one is true, but the second one is false, then only it is false. In all other cases, it is true. Therefore, these are all true. Now, what is your final observation? Your final observation is these two columns have the same, always same. So P imply Q and not Q imply not P have the same truth value. Clear? Therefore, what you can say, because they have the same truth value, so you can immediately declare that P imply Q is equivalent to not Q imply not P. We are done. Easy. So again, so the small table we have learned it. Now we are going to apply them in several places. Yeah. So that one we have already done. Now we have one more example, so that the converse and the inverse of a conditional statement are also equivalent. Now few homework also you have to do. So unless you do it, unless you solve it, you will never learn. So my suggestion to all students will be always there, that please do practice whatever we are doing it here or in your home. Do this problem, some other problem, exercise problem, assignment problem, please do solve. Look at this example. The converse and the inverse of a conditional statement are also equivalent. So how do you prove that, and what you have to prove? Converse of a, so suppose you have the conditional statement P imply Q. Then what is the converse of it? So converse of it will be Q imply P. And inverse of it is what? Not P imply not Q. What is your job? You have to prove that they are equivalent. How do you prove? Just do the truth table, the same kind of truth table. So just you see that, make this column and see that whether they have the same truth value or not. So if they have the same truth value like this, you can immediately declare that they are equivalent, right? So please take this as an exercise problem. Please finish it. It's very easy, but you will have one practice. Okay, I'll be discussing about a new proposition, compound proposition, which you called it as biconditional statement. So initially we had in the previous one we had P and Q, we had two proposition. Then we made a proposition called conditional statement. Now you are making a new proposition called biconditional statement. And how you read it? You read it as if P, if and only if. P if and only if Q. Right? And in this case, it is not only P is implying Q, it is Q is also implying P. So both of them are there. Correct? So P imply Q and Q imply P. And therefore, the whole one, P if and only Q, this will be true if P and Q have the same truth value. If both of them are true, then P imply Q, P if and only Q will be true. If both of them are false, then also P if and only Q are true. But if one of them is opposite from the other, you will immediately declare it is a false one. Right? So this is called a biconditional statement. Or sometimes you can also read it as by implications. Right? So therefore, if I want you to write the truth table, so P, Q, and P if and only Q. So what will be the truth table of it? It will be like all possible cases T, 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 F, F, T, and F, F. And therefore, because P and Q have the same truth value for the first case, therefore it is true. But in the second case, they do not have the same truth value, so this will be false. This will also be false. But the last one, P if and only Q, both of them have the same truth value, which are false. Therefore, this will be true. So this should be the truth table of P if and only Q. Clear? Now, with if you understand this truth table, I am giving you another homework. Like you just do negation of P exclusive or Q. It is equivalent to P if and only if Q. Can you prove that now? Because you know what do you mean by equivalent thing. So just take this as homework and prove that. You know the negation, what is exclusive or what is if and only if thing. Right? This you take it as homework. Just finish it. You can easily see that proof. Okay. So as I mentioned that this is the biconditional statement and we are done with this. And then biconditional statement, you can also read them as P is necessary and sufficient for Q. This is again another equivalent terminology. P is necessary and sufficient for Q. You can also see that if P then Q and conversely. In mathematical theorem, many places you will see this kind of thing will be there. P is necessary and sufficient for Q. If P then Q and conversely. Or sometime in short, you can also say that P if Q. It means also the same, that P if and only if Q. So these are different terminology. You use it for biconditional statement. I hope these are clear. And then few truth table will do, construct the truth table of the compound proposition. So you have to construct the truth table of it. So then how many variables involve? P and Q, two different variable. So we can do it in the same way, the way we have done. So now you see that it is a little bit bigger one, but the operations are as usual, and operator, odd operator, implications, right? So this is just carefully you have to apply all the rules of this truth table. Very easy. So P, Q, what else you required? You required not Q, you required P or not Q, you required P and Q, and you required the last one, P or not Q, imply P and Q. So we can easily do the truth table. It is slightly bigger, but easy as well. Just carefully you have to apply all the rules of all truth table. So four possible cases, T, 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 F, F, T, and F, F. Then if this is Q, then what is not Q? Not Q will be F, then T, F, and T. Then P or not Q, right? So P or not Q. This one I have to do. P or not Q. First one and third column. First column and third column. And OR operator. So T or F. It will be true Next one, true, but both of them are F, so it is false. One of them is true, so this is true. Then P and Q, I have to check these two column, P and Q. P and Q is what? This is true, but all cases are false because AND operator is true whenever both of them are true, otherwise it is false. Then I have an implications one, so this will imply this will imply this. So what you know about it? You know that P imply Q will be true, false if you have the first one is true and the second one is false. But these are two possible cases, T and F, T and F. So this is T will imply false, T will imply false. So these two cases should be false, and all other cases it is true. So this is the final truth table. So we have constructed the truth table of this big compound proposition. But you can observe that whatever we have learned for the small truth table, we are applying it here, and we could be able to make a big proposition truth table of that. Easy. So please do practice such kind of truth table problem. Yeah, so this is the final answer as I have done it already. And now as I mentioned already that several students have already know about this AND operator, OR operator, XOR operator, right? They have learned in physics some gate. You have understood the logic gate. So similar kind of thing. So there you had 0 and 1. So instead of 0 and 1, we have uh, true or false. So 1 will replace by T and 0 will replace by false. But the logic are same. So you also call them as Boolean variable. It has either two value, one is true or false, right? So the same thing will work here as well. So if you remember that all the formulas rule will be the similar kind. So 0 and 1 will be replaced by F and true respectively. Then AND, OR and XOR operators are same, right? Yeah, so up to that, and then all the content I have taken from this book only, Kenneth H. Rosen, Discrete Maths and its Application. I hope you enjoyed the lecture. I hope this is helpful. You may also give your feedback. We will meet in the next lecture. Thank you very much.